coming along to this month's Knots IoT. Before we get started, we do have a code of conduct in place. You don't need to read all of the words, although please do. Really, it boils down to be nice to each other. And if you're nice, then we should find that we'll have a really good meeting. If we find that anybody's breaking that code of conduct, then we will deal with it. It's as simple as that. But I know pretty much everybody here, so I'm pretty comfortable that you'll all be lovely people. Our two sponsors for tonight are JetBrains. Actually, I need to do have a concerted effort and give away these codes, because if I don't give them away, they cancel our account. So I need to make sure that I give them away. So, in fact, everybody that's here can have a JetBrains license tonight. So woohoo! And that includes you, Craig, even though you're on mute and can't see you. I will, if you give me your email address or whatever, and you can send it in a private chat if you like. Oh, there we are. I did wonder if it was that Craig. But see, I know everybody on this call now. Craig is a Loughborough guy too, so I know Craig quite well. Thank you for turning up, Craig.
You're very welcome. I'm looking forward to it.
Yeah, should be good. I've got oh, it's exit full screen. That's what I need to do. Right, good. Yeah, it should be good. So you can have a JetBrains license. I don't know if you need it, but you can have one. And if you don't need it personally, take it and give it to somebody else. But it must get activated by the time I tell you to activate it, because otherwise they expire, the codes. So woohoo, everybody wins. Always good. I put my company on here because I pay for all the web hosting and all the organization. And so I keep my personal company running in the background for reasons. So that's why they're on there. And then moving on, we've got the way that normally you would win your JetBrains license would be to send a tweet on the hashtag NotsIoT. Please do that anyway, because it gets the word out about our meetup group, and more people is always better. But that won't be a prerequisite for tonight. And sorry, if you're on YouTube watching this later, you're too late. Come along in person to the next in-person one if you possibly can, and if you can't make it, come along live to the in-person, to the Zoom meetings, and we can do all of that there. We've had a conversation, actually, Nikos and I, about becoming an MVP. And you're lucky because you've got two MVPs on this call, because Sander is also an MVP, as you're well aware. If either Craig or Larry wants to talk about MVPs now, I think, Larry, did you say that you were looking to become an MVP at some point? I seem to remember you mentioning that.
No, but I do know an awful lot of MVPs, as I was a landlord of MVPs during lockdown. So
that's right, I remember you saying, yes, perfect. So for those perhaps watching on YouTube, if you're interested in becoming an MVP, then get in touch with an MVP. In this case, either Sandra or myself, and we will discuss how you go about doing that. So yeah, it's really worthwhile doing. It's great if you're into doing this sort of thing that either Nikos is doing or I'm doing. Or blogging or open source or any of those things, then you can get rewarded with a Microsoft MVP. Tonight we have Nikos Delis. Is it Delis? I'm pronouncing your last name, by the way.
Yep, that's correct.
Cool. Good. I don't want to keep saying it the wrong way and for you to be cringing inside. Nikos will be talking about how to monitor and manage a farm of robots using Azure IoT and Digital Twins. And that last word there is probably what piqued Sander's interest just as much as robots. Digital twins. But absolutely should be a really interesting talk. Coming up next month, we've got Simon Prickett. I was hoping Simon would have come, actually. He said he was coming, but perhaps he's got waylaid. He'll be talking. He's not given me an official talk title nor much detail about what his talk is, but it's about Raspberry Pi sensors and CrateDB. So that should be interesting to hear about what that is all about. So looking forward to that. A week on Monday, is it? Yeah, a week on Monday. And I've still not managed to get this up yet because of that TBA of what David Whitney is going to be speaking about. But this is going to be in person. We do Knots in person at the BGSS offices in Nottingham. So if you're able to come along to that one, David Whitney's talks are always very interesting. He does everything from creating a Game Boy emulator in .NET to talking about how you can save your development career. David works for Newegg, the credit card company, and he is awesome. So definitely worthwhile coming along and watching that if you possibly can. It will be available on Zoom and then YouTube later, should you not be able to make it. And then that's it. So enough of me yabbering on. I'm going to stop sharing if I can actually figure out. Oh, there we go. Stop. and then we can switch over, and Nikos can give you the part where he tells you the interesting stuff.
Oh, thank you, thank you. Can you hear me?
Yes.
Fantastic. Okay. Let's see if you can see my screen as well.
Yeah, not yet.
Hopefully you can. Okay, great. Yeah, let's talk about robots.
I don't think I can see it. Is it actually you sharing? I don't know. Maybe
Yeah.
I can see it now. No, it's my fault. Carry on.
Okay, good. Yeah, let's get it started. Well, thanks for the introduction, Pete. Again, my name is Nikos Delis. I'm a senior software engineer and cloud engineer, I should mention. Freelancer. I like Azure. I work quite a lot with that. I have a few certificates. I am also writing on a blog called ndtechnique.com, where everything I do in my projects and I find challenging, I write about it. Like everything I consider not to be common knowledge, I think that, maybe I need it sometime again in the future. Let's write about it. I do have a podcast. I do. It's called Azure Triumphs, and I discuss with people who have interesting projects with Azure. But recently, I have even started doing recordings with people who discuss other matters that's concerning all of us, like diversity, inclusion, equality in the market, and stuff like that. And I am also very happy to be actively committed in the local community, the local Azure community, where I'm a part of the organizers group. I enjoyed a lot, and of course, you can find me on LinkedIn and on X by the handle ND Technique. So today we are going to talk about robots, about robotic arms, actually. And I will start the session by explaining you a little bit the background. This whole session is about a project of mine that I am not working with right now, but I did for a bit more than a year. A few months ago, I stopped with that. Then I will explain how it all started, what we did, and what we end up doing. So the company that hired me to help them with their needs is called Rebel Industries. It's a startup here in Sweden. I didn't mention that I'm located in southern Sweden, in Malmö, but this company is located in like in the middle of Sweden, a bit more in the north. And what they do, their business is that they are renting out robotic arms as consultants. So the businesses that are renting those robots are only paying for the time that they are using. And already there, you see the first need, okay, how much are we using it? So this is like the very first question. And they need to have a measurement that's not discussable. Like the customers can say that it wasn't used for an hour, or Rebel can say that it was used for the whole day. So we have to have standard measures for that. Then actually they're not selling, they're not renting out the robots. They are renting out what the robots do. And in this example that I will show in this session, the robot is doing random depalletizing, meaning that it takes a whole Euro pallet, the brown yellowish one that we see in the lorries everywhere, full of boxes, and it picks one by one and it's putting it in a band, and then it goes where it should go. So the one that I'm going to show you is doing 600, a bit more than 600 packages per hour, which is quite a lot. Of course, the customer only pays for what the robot does. It has a very short lead time, because this is one thing that I have understood, that it is a common problem with the whole IoT branch, that stuff takes a long time to be delivered. It is very well trained, but more on that a bit later. And it's a noble giant. As you will see right in the next slide, it is a huge robotic arm, which actually, one could say that if it falls on you, then you're dead, but it won't, and it will be very, very careful about everything that's surrounding it. So say hello to Clipson, a Rebel workmate. As I said, they're not robots, they're consultants, so they have workmates. And actually, the whole offering is not only the robotic arm, it is a whole control system. As you can see, there is a mega computer here an industrial size. I don't even know the specs, but I think I remember that I was amazed when they mentioned what this box has inside of it. It has quite a lot of sensors for security, sensors for understanding what is going on and all that stuff. Of course, it has a 3D scanner equipped with AI solutions to get the cloud, the point cloud, to understand where everything is. And yeah, for sure, we have the robotic arm with its various tools to be able to pick things. And now let's see it in action. Please let me know if you can see the video and hear the sound. Okay, I'm gonna pause it. Right there. Now, as you see, the packages gracefully. Now it's waiting. And what is it waiting for? It waits for that band to be done because the other packages aren't moving. So there are cameras up here taking photos every second of each package, and then comparing to photos, you can see if the package has moved. So it's actually as simple as that. Then, well, it will move the package in a very nice and gentle way. It will then very fast goes. Of course, the robot wants to do things fast, but it wants to do fast the things that it is allowed to do fast. So it wouldn't pick the robot and throw it to the band, jeopardizing the contents of the packets. It will put it gently, but it will go home very, very fast. And just the last one, see the red lights here? This is the infrared camera up there, which is taking photos. So when now we have a very nice photo here because the robotic arm isn't in the middle between the camera and the packages. So it can take a photo and very quickly analyze the image to locate the centers of each package to be able to pick the next one that's suitable. So that's pretty much all it does. And as you can see, it is very hardwired on a cement base. I think it's this is 1 metric ton, and this is 600 kilos. I'm sorry, I don't know how much this is in pounds, but it's like 6 very big adults. This one, yeah, it's a very heavy thing. Okay, so now that we saw what it does, a few questions arise. So, how many packages did Doris pick today? How fast is Adam? Or of course, we have to monitor the internals of the whole system. Like it has a hard disk, it has a network card, it has all the electronics that every IoT solution has. So we have to make sure that all those things are working properly. And in the end, of course, we also have to have metrics that are relevant to the economics of the whole project. So the success rate, so okay, it managed to pick the package, did it manage to put it in place? Did it drop the package, maybe? Did it take too long to put it in place and all that stuff? And in the last part of the project, we even managed to implement the cloud to device way. So of course, the device is sending messages to the cloud to send all this data, but sometimes we want to communicate with the robot and in automated ways. Like we have every time that we deploy a new version of the software that's running on the robotic arm, on the computer of the robotic arm, we want it to get updated by itself. And of course, we could use something like Argo City or a solution like that, but we want to do it a bit more automated. So we ask the robot to update itself. So it actually, back in the day, back in those days, it did a git by itself to draw the new package. So the whole thing is all about events. And what is an event? I hear you asking. Or actually, I don't, because I understand that you're all very, very routinated IoT developers and engineers. So you probably know that. But I think it's a misconception that's met quite often that what's the difference between an event and a message? And I say that a message is an event with a body, while an event is that something happened. It's like the value of the sensor has changed. It maybe doesn't contain the new value, but just that it changed. And it's stuff like that, so that the robot did something, or even that the robot didn't do something. Even the absence of an event is an event, and we have to be aware of that. So, for example, we have events of the robot being idle. This is also an event, even if it doesn't actually do anything. So, quite early in the process, we came up to the conclusion that it's not enough. It's not enough for the robot to be up and running. The robot has to be online. It has to be reachable. And before I jumped in the project, of course they have a VPN and everything in place, so everything is safe and nice. But they used to SSH to that mega computer connected to the machine and to check the logs there. But you know, this takes quite a lot of effort, and it also needs the people doing that to be good with Linux and to understand what they're doing. And then every time they were onboarding new robotics engineers, they had to create new certificates and all that stuff. So quite early in the process, we realized that this isn't a sustainable solution. So we thought that, okay, let's try to put a face to that monster. And by face, I mean the Grafana, or I mean a portal or something. And of course, we also have to save all this data. So we started slowly. And by slowly, I mean really slowly. This is the initial software topology. This is what was happening from day two, let's say like that. So the robotic arm, and actually not only the robotic arm, every part of that solution is producing events. And those events are captured in one way or another in hardware, and they are all streamlined to the mega computer. I'm sorry. And then the computer is publishing those messages in an MQTT server, which is also running on that computer. So this was the start of everything. No matter what happens, put it in a message, throw it in a topic. If anybody's interesting, subscribe to the topic. So this is where it all started. And what they were doing in the beginning is that they actively, with a terminal, created a subscription to the topic, expecting the messages to pick up. They had a very big screen in the middle of the office where they were looking for the messages. And then they took pictures with their phone and analyzed the contents of the messages. Yeah, it sounds primitive, but this is what you do when you don't have the tools to do what you need to do. So the thing is that I like IoT, but in heart, I am a developer and I always will be. And when I see something like that, I see Jason. I don't know what you see, but I think I see something that can be done to objects and classes and stuff that I know how to manage. So first step, very first step, let's create a console application. Yeah, a simple console application. .NET, .NET Core, if I'm not mistaken. No, it was .NET 6 actually. A .NET 6 console application, subscribing to all the topics initially, maybe for a day or two. Then it was flooded, and I only subscribed to the topics that actually were interesting for me. And the first thing to do is to save all those messages to a Mongo database. Let's save them there, and then we'll see what we'll do with them. And in the meantime, except from saving the messages in Mongo database, I was also sending them to Azure IoT Hub, which is the place where all messages go to be distributed to wherever they need to go. From there, I had a stream analytics job, which picked all those messages and canalized them to various outputs. I'll get to that. Now, an issue with this solution is that this is .NET 6, and the machine is running Ubuntu. and it doesn't really work out of the box. So I have to install .NET on this robot. And as you remember in the beginning of the session, I didn't talk about the robot, I talked about the farm of robots. So I don't want to install software in 20 machines. I want it to work out of the box. So, and every time I upgrade the version of .NET, I don't want to upgrade the .NET SDK as well. I just want it to work out of the box. I believe that you see where I'm going with that. Here comes containers. So let's containerize the application. Yeah, let's containerize the application. And instead of having to manually install all the SDKs, let's put it in the Docker file. Let's have it solve it by itself. So I actually even put Mongo in a container. I regretted that. I shouldn't have done that. But yeah, I did. And I then doing a container and then still having to do Docker pull instead of Git pull is just stupid. So just put everything in a container registry, and with GitHub Actions, I updated the registry so everything worked smoothly. And now we have a working solution to be able to pick the messages, send them where they need to be sent, and save them in Mongo. That's it. Nothing else. No processing, nothing. Now, the thing is that I started having questions about how this thing fails. And the thing about how this thing fails when I'm running in Docker is that I can't see the mother host because Docker is my new host. So what did we do? A node application. Yep, a node application with the appropriate packages. It could collect all kinds of data, and in practice, it is actually an API. And then since those two, I'm sorry, that should be the one. Since though this is running in the same network as the rest of the applications, those two talk to each other on localhost. So this one has its port, this one has its port. It collects data like every minute or something, and this is asking for heartbeats. We call that the spy. Then a terrible thing happened. Remember that I told you that I had Mongo in Docker? Apparently there is a limit of how much data you can have in a container in Docker, and I reached that limit, and then Docker wouldn't start. So I had to manually delete the log file, but I will never forget the fear of losing all the data, because that data was being the basis of the invoice that was going to be sent to the client. So I'm sorry. The very next step was to make sure that the data from Mongo do not disappear. And here comes another console application. But this time, this application is not dependent on the IoT functionality, which I also have to mention that this one had started to cost quite a lot because we were kind of abusing it. So this one takes all the documents, converts them to JSON, sends them to an Azure function. We're cheap, I'm telling you, we're cheap, which converts them to blobs and saves them here. And now the blobs have names that are understandable by humans. So if something went wrong yesterday in the middle of the day, they know which file contains the logs of what they're looking for. And it also has some metadata, like what dates are the log of the logs contained in those files. And then another Azure function in the same serverless function app is looking on those metadata every day. And if a log is older than a week, then it's probably never going to be needed. So we put it in archive. And this was a rather fun application. We called it the ankle. So what we aimed for was to, if possible, to make sure that we never have data loss. Because if you have data loss, then we don't have awareness. And this whole project is about awareness. Let's see. One moment. Thanks. Okay. So what we do to make sure that we don't lose data? Step one, we save everything in Mongo directly. The moment we pick the message, before we do anything with it, we save it in Mongo. Then we send it to the Azure IoT Hub, which in its tour, it sends it to a Cosmos database and to Grafana and to the Digital Twins. And then on the last step, we also have the uncle who is taking backups of everything. Now, very good, we have all the data. What about it? Well, data by itself, it doesn't say a lot. What we need is the information that's behind the data. And if the information is what is the mean time of everything, what is the number of packages per hour, then we have to wait for an hour to pass. And after that hour passes, then we can make a very simple calculation and send up the result instead of sending all those useless logs. And this is what we did. We had some real-time data, like that the robot is up and running, we're good. We have the digital twin to display every very immediate error that has to be communicated directly. And we also have any weird interactions being reported directly. But for all the rest, we have, which we call processed data, we do the processing in the edge, in the computer by the robot. We don't do it on the cloud. And I think that this is smart because we don't want to use cloud resources which cost while we have a mega computer there to do all that. We just report the results. And another good thing is that the client had access to the source code of the agent that was performing those calculations. So they could also confirm that the calculations were right and everybody's happy. Now, okay, that was some theory. Let's see now what the operator used to see. This was the first take. And this is a digital twin. I will explain you in a while why we needed the digital twins. But before that, this is Power BI, the default table you get from Power BI. It isn't very beautiful, right? And what's even less beautiful is that this thing needs a license to operate, and the license costs, and we don't like things to cost. So we had another tool called Grafana, which is open source. We like it. There is managed Grafana in Azure. Or if you want to get a bit more gray hair, then you can try to deploy Grafana by yourself in an app service, like I did. And then you can get a bit more beautiful grids like this one, which is what the people who care about numbers can see. Like every hour we have this many packages picked, and this is like the activity of the robot, of course. For the bigger part of the day, it doesn't work a lot, but then we have quite some activity, and then they can see if this is a good deal for them or not, and all that stuff. And this is quite interesting. Then, of course, we had the people who we like the most, the nerds, that were interested in more granular data. And actually, this doesn't have to be very granular to understand that something died here. But people who are using dashboards like that are like cardiologists. They can see anomalies in very, very small data segments. And we had quite a lot of those. Now, I don't think that when all these projects that you saw was created in between Christmas and for sure before summer vacation. So 3 months, maybe 4, maybe 5. That's about it. And it wouldn't have happened without the tools we got from the IoT platform in Azure. So the overall architecture ended up looking something like that. We have quite many messages arriving in Azure IoT Hub. From there, we had the Stream Analytics job, picking those messages and sending them to PostgreSQL, again, open source and cheap, and to Cosmos for some scarce metrics. From there, Grafana can easily pick those tables and display them very nicely so that humans understand. And we also had an Azure function with an event grid subscription, picking the messages from Azure IoT Hub and displaying those beautifully in an Azure Digital Twin. So why the Azure IoT Hub? Well, first of all, it has the message-based architecture, which I know that there are other services that offer that, but the fact that we could very easily onboard a new device, just get a connection string with a private endpoint, put it up, and it works. Nothing else. The fact that we had a great SDK, which we could very easily come up with and implement and start sending messages, also helped a lot. It has integration with all the other services we needed. It has the great cloud to device message service, which we also needed in case we needed to restart the robot, for example. Then, as you remember, after that, I had the stream analytics job. And what this does, actually, I can show you in a minute, but it takes the input. It can perform some processing, which I did in the beginning, but I ended up doing it on the edge. And then it puts those values in an output. It can filter data, which is a great tool if you want to canalize the data as you want. And the best feature is that you can pause and you can rewind. So you write your query. If you're not satisfied with that, you can run it again from 10 minutes ago or something like that. And then you can reprocess your messages. And this made the developer's experience quite pleasant, if I may say. Then to display the data, Power BI didn't really fly for us. We get a lot of advantages using Grafana, and the access control is just one of those. So we could integrate it. And of course, I know that you can do it with Power BI as well, but I liked it more the way Grafana did it because we just connected it to Entra, as it's called now. And it had a lot of ready dashboards that we could just throw in, and it worked right away. And then the digital twin gives us a quick overview and a call to action. And as maybe you saw in the video that I showed in the beginning, you saw a few gentlemen running like from one corner to the other. This thing is running in a huge space where people can't have their eyes on the robot all the time, and they need to be directly notified if something's wrong. So what they did is that they put screens like usual monitors in many places that was just displaying the digital twin instead of the actual robot. And it even had certain parts of the robots marked as red or green if everything's good, red if something's not good. And this made the whole thing viable for them because they knew directly that, okay, now we have to run and check if something's wrong and all that stuff. Now, how to get started with digital twins? I always have this slide because I could never find good documentation about that, and I have to pick a little bit from here, a little bit from there to put it together. So I put everything in a slide, and here it's for you. And I will show you in a demo, of course. But what you do is that first you have to define your twin, like in relations, like in a database. Then you create your twin importing the data, and maybe dummy data or real data, it's up to you. And then you have to do the 3D scene to do the beautiful thing there. After that, you can connect various components of your twins, called meshes, to various actions to change their behavior. And their behavior might be some color, it might be a badge or something. So that's it. And now I'm ready for questions, but before the questions, let me show you a few fun things. So can you see Azure now? Hopefully. Yeah, okay.
It's a bit small. It's a bit small. Might want to zoom in.
Small? Yeah, I'm zooming in.
Yeah, I guess your screen resolution is like 4K.
Okay.
Might want to switch to 1080p if you want. Might be easier on that monitor, that is.
Okay. I hope that's good now.
Yeah, that's better. But just
Okay.
more space, I guess, now. But maybe you could minimize bits of it.
Yeah, let's see. Let's put that
Yeah,
away.
that okay.
Okay, yeah, good.
Yeah, that works.
So actually the whole thing is this statement here, because right after that I have a number of selects, select blah 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 blah, into, and this is where the output goes. This is a database table. From input, and what is input? Input is, come on, input is here. So the thing that costs performance is this. This is the only time in my query where I pick things from the IoT hub. Then anything that I'm doing here doesn't have to do with the IoT hub at all. So I pick all the messages that I can in that session, and then depending on the robot name, in that case, and the message type, I'm putting the message in the appropriate output. So this is the PAL output. This is the verbose, where everything goes. This is the status, and so on and so forth. So before having this, I had enormous performance issues because I was running all the selects that I have down there to each and every message it was picking. And I think that somebody in Stack Overflow, I was desperate. I really was. I was asking a whale, and somebody mentioned that I should be doing that. And since then, I'm running in a third of a unit for the whole thing. And this was great today. And then the digital twin, and everything I'm showing you now is in test, so it's not real data, and it's very old data as well. It's from the summer in best. Actually, here we don't have any endpoints, but here is where we would declare any endpoints that are available to be able to change the behavior of the twins. But if we take a look in the Explorer, which is the cool part, then in here, I have my models, and I have declared 3 of those. So first we have the organization, which is the company who owns that owns all the robots. Then we have the robot farm, and then we have the robot. So if I run my query, because I have indeed imported some data here, I have one organization, then I have 2 farms. One is the lab where we're playing with the robotic arms, and the other is the customer. And then I have one robot at the customer called Black Panther, and one robot in the lab. Now, the interesting part about those are the properties, the twin properties. And these are the ones that we are updating. So I have created a very little demo for you. Let's see now if I can have both screens here. That's nice. Okay. So this is the 3D scenes, the 3D scene where I can change everything. And this is my model. I hope that it is visible by you. So this is a GLTB, if I remember correctly, file. And as you can see, as I'm hovering with my mouse, I can pick any part of the robotic arm and connect it to a property. I can declare it as an element and say that your behavior is going to be dependent on a certain property. So I pick that one, and I have created one mesh. And yeah, I declared that mesh, and then I have created behavior on that, which is the change color by status. And what it does is that it has a twin, which is the status integer value. And I pick the integer because it's the one that's easier to change. And according to that, it will apply a visual rule. So if it's 1 or bigger, it will be green. Otherwise, it will be red. So now this was the build view. If we go to the view mode, it is red, as you can see here. And if I change that to 1 and save, let's give it a moment. Come on. It can take up to a minute, I think. Yeah, green it is. If I change it back to 0, then it becomes red. So this is a small demo of the digital twin. Now imagine that we don't have a person sitting and changing those values, but those are the reactions of whatever is happening to the robot. And by this way, we can display this thing in a screen and everybody understands what's wrong with the robot. And that was pretty much all I had to share. Let's discuss. Are there any questions?
That was really good. Thank you very much.
Thank you.
Yeah, Sander's got all the questions. Sander, did you just want to come off mute and ask all of your questions? The ones that haven't already been answered by listening to the talk, that is.
Yes, hello. Yeah, thank you for the great presentation. This is a nice example of a. Am I still there?
Yeah,
You
yeah,
are?
yeah.
Yeah, okay.
Yeah. I will rush in a minute because I'm sensing that the alarm is going to go off. But
yeah.
please, I will
Yeah.
come back right away. Yeah, please.
That's okay. Until that, I want to say that's a nice example of a industrial solution. There were a couple of questions that I had.
Yeah.
First of all, it looks like there's a solution with software being deployed as containers on each robot. Is that true? Each robot has
Yeah.
its own compute?
Yeah, that's correct. And this is correct. This is by choice because not each robot has the same functionality, and some are doing depalletizing, others are doing other tasks, and we're not comfortable deploying a new code to all the robots automatically because it's one thing having one robot broken, it's another thing to have 50 robots broken. So yeah.
Have you considered having an edge device, a device that runs on the edge of the local network with a cloud connection, and have
To be
all
honest,
the robots connected to that edge device?
yeah, to be honest, in effect, that's what we were looking for, but we hadn't discovered the Azure IoT Edge when we were building that. So yeah, you're completely right. That's exactly what we're looking for. We just didn't know it existed.
Yeah, because a couple of things that you invented for your system.
I guess are working out of the box.
Yeah.
Probably much better also.
Okay, but then you're running locally a database, and that's which wasn't it?
Mongo.
MongoDB, which is
Yeah.
a NoSQL database.
That's right.
It's not optimized for time series data like InfluxDB.
No, it's a disaster.
Did you consider a database, a more time series like database?
Just to interrupt there, just before you move off on that, I know somebody that works at MongoDB and they are working on that as a problem. I think actually it's already there.
I'm very sorry for my comment.
Oh, no, it's fine. And they recognize this same thing, but
it's another kind of
content.
database. It has a different use case.
It does, but they're adding a time series facility to it, interestingly.
Yeah.
Okay.
Yeah.
Well, it was a no-brainer, and that's because the status of the JSON scheme was changing every day. So we never considered anything that had any kind of scheme. It had to be fluid. Then, if there are databases that do support document like behavior and are time series optimized, then please let me know because I was desperately looking for something. And I said that it was a disaster. Of course, okay, it wasn't a disaster, but we had a lot of challenging when we tried to pick the logs between a certain date, and then the date was saved as a string. So so we had to convert those to date times and then do date operations and stuff like that.
Okay.
Yeah.
Yeah, that's real life stuff, and this is the challenge that we face in an industrial environment. It's always different because the production being productive is more important than all the stuff that we do.
Exactly.
So we have to be very fluent with what we try to achieve, and in iterations we have to think in iterations. Yeah, that's I see a lot of stuff that I have encountered also.
I'm happy to hear it.
So I also saw that you have a Postgres database in the cloud.
Yeah, that's true.
Did you consider other databases? Also, Postgres is, for as far as I know, not a time series database.
No,
Did you
I
consider
think
InfluxDB or
we
Crate?
only say process the data there. So uh, yeah, we didn't really have the need for that there. But
Yeah,
what I
that's
did consider was to use the Azure Data Explorer for near real-time statistics and stuff like that. But yeah, we never really got there.
well, the fact that your data is mostly already aggregated
Yeah.
and beautified towards the use case on the edge.
Mm.
I expect with a Docker container logic, not some program that you have to deploy everywhere,
Mm.
but in a more smart way to deploy it. Yeah, you can hit some performance limitations if you don't have a time series database. Grafana is really fond of data that's has a timestamp.
Yeah, I can imagine. Yeah.
So Azure Data Explorer could also be a solution, but that's not free. There's
No, of
a
course.
penalty regarding the costs, but you are buying a monster. You are buying so much compute with that
Yeah.
you can do additional compute in the cloud. Um, I'm, but Postgres is working as expected.
Yeah, actually. No
Okay,
problem at all. The only
yeah,
thing that's expected by it is to store the data in a simple table with an index on the date field, and then it's Grafana that's taking over and doing all the aggregations and groupings and stuff like that.
really nice.
Mm.
Did you use managed Grafana as your managed?
No, no, I deployed it in an app service in a container.
Yeah,
Yeah, it's all right to do
We're saving money everywhere we can. That's, poor man's
that,
solution.
yeah. That's that's a solution because you said running Grafana in Azure. Well, there's also some costs involved there.
Of course.
It's a couple of pounds per month per use. Because I was asking in thinking about if you run into some limitations. The managed Grafana does not support all the features.
Yeah.
I believe the add-ons, for example, is something that
Yeah,
is.
that was also one reason why we didn't run with Manus Grafana. The only advantage we saw is that it was pre-configured to work with Entra
Yeah,
smoothly, but it
that,
wasn't too much of a headache to configure it manually. So yeah.
yeah, because that's actually a really strong point of managed Grafana.
Mhm.
Integration with Entra ID. Yeah. Um, I was also looking at the well, you told about the stream analytics job
Mhm.
at having problems. Well, if you reuse the same input multiple times, that
Mhm.
will all be consumers of the same event hub compatible message stream from the IoT
Yeah.
hub. So
Uh,
you
uh,
will, in the end, run into the maximum amount of consumers on a consumer group, on the
Indeed.
same consumer group.
Yeah, that's true. But we didn't have multiple consumer. We had only one consumer per group.
Well, if you do select star from input for output to something,
Yeah.
and select star from input output to something else,
Oh,
that's
yeah,
two
yeah, yeah.
different consumers on the
Yeah.
same consumer group. So once you hit 5,
Hmm.
it will crash on you.
Exactly, but that's what we solved with the with
Yeah.
statement. Yeah,
Yeah, and if you do the with, then you only have once and it's kept in memory, and then it's
yeah,
reused by every subquery behind it.
exactly. Yeah,
I,
they should write that in bold letters in the documentation.
yeah, I run into the same issue, and luckily I was able to think ahead. But that's sometimes you're lucky, sometimes you're not. But
Yeah, that's right.
this is stuff for a blog post.
Yeah, that's
And
great. Yeah.
last but not least, I was hoping that we could see the real Monty with all the twins. But
Yeah, that
we got the demonstration, which is okay. Uh,
yeah. I
but
would
how
love to
many,
show that, but since I left the project, I don't have access to that anymore, and I'm not even sure what they did with that. But
well,
it was
it's
a majestic one.
okay. You don't want to disclose customer information.
No, of
Uh,
course.
but how many twins are there running?
10.
10. Oh, that's still okay, because if you have more, you at some point will, and no, I think you have encountered that if you want to update the DTDL, if you have
Mm,
a change and you have to update it, you have to
mm.
deploy it to every twin again. But that means
Oh,
they have to delete them and create them again.
oh God. Okay. Well, that's yeah. It's good that we didn't have that more than 10.
Yeah, well, yeah, I was hoping that you had a solution for that. Because this is one of the little things that are making Azure Digital Twins a little bit cumbersome.
Mm,
Want to update DTDLs, especially if you have a hierarchy, and
mm,
these are room number version 3 is related to building number 3.
no,
So
correct. Yeah.
building 3 goes to 4.
Mm,
How about all the rooms?
mm.
Oh,
So,
Craig's got his hand up. Craig.
Yeah, I've got a question actually. So don't want to interrupt anything, but I just put my hand up.
Go ahead.
Yeah, okay. So Nikos, great,
Yeah.
great demo. Really interested in
Thank
all the
you.
tech, and some of that I'm not familiar with. Some I am. I'm interested though. What's the development lifecycle look like? So if you identify a change that's required, either that's perhaps you found a defect through the data, or there's some change required by the customer. They
Mm,
want different metrics, or there's a different products that you want to depalletize.
mm.
What's the kind of the cycle look like in terms of updating code, testing, deploying, and then the kind of validation at the end?
Yeah, well, we tried to scope the things. So we had one scope called verbose, which actually is all the messages that we ever get, all of it. So in the end, this is our final fallback. If we can't find a way to process, to calculate the information with events that we have, then we turn to the verbose logs, and there we even have every single lamp, everything, every single device in the robot. And sometimes we did have to dig this deep to extract data, but the process was to start as high as possible, see if we can do it in Grafana with the data that we already have. If not, then maybe we need to pre-calculate something on the edge. And if we didn't have the tools there either, then we had to talk to the robotics engineers and ask them to send events for those things that were needed. A good example of that is a customer was asking about how much time is wasted by operators, and that means that the robot has signed it. It has somehow. And by an alarm, by something, told the operator that now you need to intervene, now you need to do something. And then the operator is a human being. We can't know when they will do it. and sometimes they just went home and never did it. And then the robot wasn't working for the whole night while it was supposed to be. So obviously the customer was interested to know whose mistake it is. So yeah, in that case, we went back to the robotics engineers and we're telling them that we need events even for things that are not happening. And I'm not sure if it answers your question.
Yeah, partially. I was interested in, as well in the sort of the deployment of the updated code.
Oh, the deployment. First of all, we all take a batch of logs from the robot and run it in an emulator in our local machine. So I do have an MQTT server in my Docker, in my local developer machine. I'm sending the logs there, and I'm trying to emulate the whole process to watch if the calculations are doing correctly. Then when I'm satisfied with my code, I push it up, GitHub, Azure Container Registry, device, cloud to device, asking the robot to update itself. So it's running a new instance of the agent and it kills itself, the one that was already running. That's the process.
Okay.
Yeah.
Thank you.
Sander?
Yes, I was triggered by the protocols. Protocols is always the part where you have to interact with with the engineer.
Yeah.
Which protocol is the robot talking towards your software?
MQTT.
So they have a MT client in the
Yeah.
robot to forward it to the MQT broker locally.
Exactly.
And your software is also a client and listening to the right topics.
That's right. Yeah, exactly. So it's
Okay.
MQTT from the robot. They have an agent written in Python that's publishing messages to the local MQTT server.
Yeah.
Upon which I'm subscribing, doing my pre-processing, and then I publish MQTT messages to Azure.
Yeah.
That's how we did
To
it.
the IoT app. Yeah.
Yeah, exactly. Yeah.
Oh, very good. Are you also making use of the because the IoT Hub client is living inside the agent? So do you also make use of cloud to device messages?
Yeah, yeah. That's what I mentioned
That's
earlier.
for the
That
reset.
exactly. Yeah, and it's only not only to do Docker pull and pick the new versions of software. It's even to ask it, for example, to take a break if the robot is getting too warm, then we can in that way easily. Actually, they're doing it with a power up. They're asking the robot to take a break and go slower, because if it has a lot of success and it's picking packages very fast, and it gets warm, and that's not very good for the longevity of the robot. We don't want it. So yeah.
So you're already, it's not only remote monitoring, but you're already doing some kind of
Yeah.
predictive maintenance
Exactly. It's
or interacting with robot to, in this case, slow down.
correct. Yeah.
Oh, very good. Very nice. One last question. They
Yeah.
are looking at the belt if there's a package over there with a camera
Yeah.
to have the robot wait for
Exactly. To not put another package upon the existing ones.
Why was that done with a camera instead of a array of infrared lights or sonic or whatever? Because
Yeah.
working with a camera, that's with probability. Yeah, it's 99% of the time it works fine, except when
Exactly.
it suddenly pitch dark.
Yeah. I think that it's faster for the team to get the solution up and running with a camera, and they already have the camera. While the point cloud is a very expensive solution, and they only use it to pick the packages on the correct place. Also, the band is moving they can't control how, because they sometimes they do bigger packages, sometimes they do smaller packages, and they use the robot in various places. They do have the freedom to move it, and if they did the infrared beams thing, then they should send their engineer every time to recalculate everything. While with the camera, it has an automatic detection of the package, and they just have to place it in a way that it can look to the band.
Okay.
Yeah.
Well, yeah, the one of the advantages is that it's self-contained. It's not a
Yeah.
robot and a belt. It's just a
Mhm.
robot.
Yeah,
Yeah.
I can imagine. I believe that a lot of they have a microservices mindset. So every little piece of the solution can be taken from that and put in another solution. So even the camera is somehow sending a yes/no signal to the PLC that is the final controller of everything. But I'm not sure about the specifics of that. All those things are done by the robotic engineers.
Yeah.
Yeah.
Well, yeah, it's always interesting to learn a
Mm,
little bit about the engineers, because at some point we have to interact with them regarding the message format and the protocol.
of course.
If we
Yeah.
know a little bit more about the requirements that they faced and the solution that they
Mm,
made,
mhm.
you are prepared as a IoT developer.
Yeah. Actually, now
For
that you said
the
that, one very big challenge that we had is that there was no, and there is no guarantee that the messages are coming in the right order or they're coming at the moment they are published. Because they have various layers in their solutions, and it's caching things, it meets deadlocks and bottlenecks. So in some cases, we have delays of several seconds. And this is also one reason why we do the pre-processing on the edge. So we have like a pallet started event, and from there, all the packages that are coming after that event belong to that pallet until we get the pallet completed event. But the pallet completed event does not come until the first package of the second pallet.
Yeah.
So yeah, it's it's an arbitrary process, but that's real life. I mean, and yeah, I guess that's why I like the project that much also.
Nikos, did you consider other protocols beside the MQTT? Was MQTT widely supported by the PLCs, or was that only supported on the high end
No,
PLCs? How did you find that?
we did, and the first we tried was the HTTP protocol, actually, the one out of the box with the SDK. But quickly we ran into issues with that, and we had to implement retry logic on both ends ourselves. So when we found MQTT with all its inbuilt retry policies and everything, it was like a no-brainer.
Okay, and it's well supported by the PLCs?
Um, it is, but it doesn't matter because everything goes through my agent. So we don't forward the messages directly from the robot's MQTT to the Azure's MQTT. We pick them in the agent, we pre-process them, and then we publish.
Well,
Okay.
MQTT is the de facto standard at this moment within IoT world. Yes, we can also see OpenCUA, but
AMQP.
AMQP, yeah.
but
Yeah.
Sometimes.
EtherCAT in industrial settings?
I have seen that sometimes a license is needed. So sometimes the protocol choice is made on costs, is based on costs.
Yeah.
I have one customer who uses UDP just to save money.
Interesting.
Cool.
Hmm?
Cool. Any more questions? Wow, good.
Well, thanks a lot for attending my session. I'm really happy we had the chance to do this, and thanks for the great feedback and discussions. I will definitely be joining more of your sessions.
Yeah, brilliant. Yeah, please do. And Andrew, it turns out you're in Nottingham as well, so that's awesome to hear that. Please do come along to .NET Knots if that's something you'd be interested in. Being as you're in Nottingham or around Nottingham, it would be within your reach to do that. Should you be interested? But there's free drinks and free food. So for me, that's enough reason to go to these sorts of things alone. It's a bonus to get some interesting content as well. By the way, I figured out what that talk is now. I've sorted that. So David Whitney will be talking about how to build a 3D game engine in C#. So I chose that for me. This is great. When you organize your own meetups, you can choose the talk you think is going to be the best for you, and then hope everybody else gets the same benefit out of it. But I like all that sort of stuff. He's mentioned the word Wolfenstein in there, and I'm old enough to remember that. So, so that should be good. But yeah, Rebel Recruiters, they sponsor our food, and then BGSS sponsor the drink. So there's always some alcoholic drinks there and pizza quite often. So yeah, worth coming along just for that, like I say. Thanks so much. Oh, go on, sorry.
When is it?
That is a week on Monday, so the 30th of September. Good point. So yeah, if you're interested in coming to that, and same for you, Craig, if you're interested in coming along. I tend to go, just out of interest, I tend to go earlier because I like to avoid the traffic and then come back afterwards. But, should you be willing to do that, you could car share if you wanted to, Craig, and just come with me, but you'd be coming in earlier. So you've got a job to do as well. I imagine that you'd want to come on your own, but we'll speak about that.
Yeah, okay. Thanks for that.
Yeah, no worries. All right, and again, thanks to Nikos for his talk. That was awesome, great stuff.
Thanks for having me.
Yeah, we should have
evening, everybody.
Yes, we should have Simon Prickett next month on the 10th of October. I think it is. We're early because I'm speaking in. And he's gone. Nikos is gone. I'm speaking in Porto, NDC Porto, the following week. So we're having to do it slightly earlier next month. So other than that, we'll catch you next month. So thanks for coming, folks. Cheers. See you later.
Thanks for hosting.